Hi everyone and welcome to this session. I hope all of you are doing great and I hope the audio and video everything is fine. We are about to say goodbye to 2018, which has been a very struggling year for you, I assume. Can all of you hear me? All of you can hear me, please saying yes, no, or hi, bye, whatever. Hi. Okay, fantastic. All right. Yes. So yeah, it has been a very struggling year in general. 2018. Everyone who's in 12th standard, it is always a very struggling year, right? And at this point of time, you probably have not celebrated Diwali. You probably will not celebrate New Year. You will definitely not celebrate Holi, right? But this is all going to be worth it. I can tell you that by personal experience, right? So we are in the 4th session, right? We have updated the slides as well. Yeah, we have updated the slides as well. The sessions which go from 6 p.m. to 10 p.m. right? 4 sessions: CBSE 11th, CBSE Physics 11th, Physics 12th, Chemistry and Maths, right? And today's session is EMI, AC and EM waves. We'll do a couple of very specific questions on EM waves which are asked, right? Apart from that, we'll concentrate majorly on EMI and AC. Right? Remember, the idea of this session is to not give you the questions which will be asked in the examination. Nobody can do that, right? But very important part of these sessions, the only way that you can make these sessions meaningful is by noting what topics these questions are coming from and concentrating on those topics. Do more questions on those topics. Yes, EM waves is very important. At least 1 or 2 questions are asked every year from that chapter. राइट ओके सो EM वेव्स बहुत ज़्यादा ज़रूरी है, AC EMI ये तीनों चैप्टर्स बहुत ज़्यादा ज़रूरी हैं, राइट? एंड बहुत सिंपल हैं, कंप्लीटली फॉर्मूला बेस्ड क्वेश्चंस आते हैं यहाँ से एग्जैक्टली इन JEE Main, राइट? नहीं, the questions are not tough. The questions, see, I've always told you JEE Main will never ask you tough questions. JEE Main is about knowledge and how quickly can you apply that knowledge. 90 questions in 180 minutes. When someone asks you to solve 90 questions in 180 minutes, it means they will not ask you tough questions. Same is true for NEET. NEET may be same story here. 180 questions in 180 minutes. Obviously, difficult questions will not be asked. Okay? So keep that in mind. All you have to do is remove the silly mistakes. Right? Do not make silly mistakes. So this is the session. I gave you the good news yesterday. Optics will be taken by Namo Sir, but optics will be taken on 3rd of Jan. Right, on 1st of Jan we will have modern physics. On 2nd of Jan we'll have modern physics part 2. Yes, KVBY is tougher than JEE Main. Is that fine, everyone? Okay, small change over here. I'm not writing that down because all of you are aware of that. Finally, these are the sessions of class 11th physics taken by great Namo Sir. Over here also there is one change. Instead of 31st December, elasticity will be on 1st of Jan. Right? Similarly, you have maths by Pulkit and Shimon Sir, and chemistry by these 3 very great teachers. I wore it on the first day and in the second day, right? I think that is about enough, right? So this is basically the schedule that I give you every day, and apart from that, this is something that I tell you every day. If you haven't subscribed to Vedantu, make sure that you subscribe because we will be uploading more and more awesome videos to crack all of your upcoming examinations in a series. Right? Also, if you like this series, if you like the channel, if you like the videos, make sure you share them, right? It's obviously good to share the love. And ultimately, if you like this specific video, in the end, make sure that you press the like button. All right? Very simple, very basic exercises. If you do not like for any reason, make sure you leave a comment. If you like also, you can leave a comment. I would love to hear some praises as well. Now, let's start with the questions. Everyone, thank you. Utkarsh. First question we have over here. In a coil of resistance 100 ohms, a current is induced by changing the magnetic flux through it as shown. Right? So flux जो है change कर रहे हैं हम और उसकी वजह से current induce हो रहा है. Okay? Now the magnitude of the change in flux is how much is what we want to find out. Change in flux निकालना है हमें. Again we will start with the very basic of concepts on how to do this. कैसे करेंगे इसको? There are 2 things that we need to know, right? हमें resistance given है and हमें current and time का graph given है. हमें क्या निकालना है? Change in flux. So what do we know here? We know that d phi, right, by dt is equal to E. The EMF that is induced, is that right? And that EMF that is induced is equal to current into resistance. एकदम बेसिक बता रहा हूं मैं यहां पे, कुछ भी नया नहीं है. दिस इज वन डेफिनेशन दैट यू आर अवेयर ऑफ. पहली चीज जो आप पढ़ते हैं EMI में, एंड दिस इज ओम्स लॉ एसेंशियली, राइट? सो दिस इज व्हाट यू हैव. हमें d phi निकालना है. अगर मुझे d phi निकालना है तो मैं क्या करूंगा? d phi को आई विल कीप ऑन द LHS साइड, आई विल मूव एवरीथिंग ऑन द RHS साइड. आई हैव r I dt. I dt is this graph that you are given. Values नहीं given है आपको, graph given है, ठीक है? So if I want to find out flux, flux will be given by what? Flux will be given by the integral of d phi, which will be given by the integral of r, बाहर ले लेता हूं, constant है I dt. And if you have read integration, you know that this represents area of this curve. Exactly, very good Utkarsh, that's absolutely right. इसका एरिया निकाल के यहाँ पे सब्स्टिट्यूट करना है. फाइंड आउट दिस एरिया, सब्स्टिट्यूट दैट ओवर हियर, एंड यू विल गेट द आंसर. एज सिंपल एज दैट. What did we do here? We applied 2 or 3 basic, very basic concepts. Keep your head down, remember the definitions, follow them, you'll get the answer. Right? So what is the right answer, everyone? Right answer बता दो जल्दी. All of you are saying B. Fantastic. Yes, B is the right answer. Right? B is the right answer. That is very good. Okay, moving on. Next question. Next question, the graph question, right? That's okay. Raj Rishi, what you can do is you can go back, right, and watch it from the beginning. The variation of induced EMF with time in a coil is what you want to find out. Right, if a short bar magnet is moved along the axis with constant velocity. No, we did find the change, right? Chirag, in the previous question, we figured out d phi. D phi is change, D represents change, delta. Anyway, so I'll go back to that question in a short while to remove your doubt, but in the meantime, everyone focus on this question. एक bar magnet है which is moving towards a coil. When a bar magnet moves towards a coil with constant velocity, what happens? जो the flux that is passing through this coil, that is changing, that is increasing, right? That goes on increasing. So वो यहां तक increase होगा और उसके बाद वो decrease होना start हो जाएगा. Is that right, everyone? So initially when it is increasing, the EMF will be induced in one direction. When it starts decreasing, the EMF will be induced in the opposite direction, right? In one direction. एक बार जब वो increase हो रहा है तब EMF induce होगा in one particular direction. Let's say that is positive. जब बाहर निकलेगा तब it will be induced in the opposite direction. We want a graph which shows that. इस ग्राफ में या इस ग्राफ में या इस ग्राफ में, तीनों ही ग्राफ्स में EMF इंक्रीज और डिक्रीज तो हो रहा है, बट साइन चेंज नहीं हो रहा है. पॉजिटिव पॉजिटिव पॉजिटिव, राइट एवरीवन? पॉजिटिव पॉजिटिव पॉजिटिव, वी डोंट वांट दैट, राइट? आई मीन 2 मिनट के लिए भूल जाते हैं कि जब फ्लक्स इंक्रीज होगा तो EMF नेगेटिव जाएगा. अभी 2 मिनट के लिए सिर्फ इसको भूल जाते हैं. लेट्स जस्ट ट्राई एंड अंडरस्टैंड दैट आई वांट अ ग्राफ व्हिच हैज बोथ पॉजिटिव एंड नेगेटिव. खाली पॉजिटिव से नहीं काम चलेगा. ओके, सिर्फ इतना याद रखते हैं, राइट? इट डजंट मैटर कि ग्राफ ऐसे बना है या ऐसे बना है, दैट इज द सेकंड पॉइंट. बट अगर मैं सिर्फ ये ग्राफ देखूं, आई स्ट्रेट अवे नो कि यार यहां तो EMF सारे कांस्टेंट है, आई मीन विद अ कांस्टेंट डायरेक्शन, राइट? सो स्ट्रेट अवे योर आंसर इज बी. Right? Straight away your answer is B. You can break it down further. You know that EMF is given by minus d phi by dt. So initially the flux will increase. If flux is increasing, EMF should decrease. Right? EMF should decrease. तो ये भी गया और ये भी गया, दोनों में increase हो रहा था, ये दोनों बचे हैं. Right? It will go on decreasing up to a certain point. When your EMF changes direction, now what happens is, इसके बाद जब यहां से बाहर निकलेगा, flux starts decreasing. जब flux decrease होगा, then EMF will start increasing in the opposite direction. Opposite direction. Sign will change. यहां पे sign change नहीं हो रहा है. Hence this is right. Okay? All right. अगर SHM करेगा तो ये भी SHM करेगा ना? Very good question, right? But this is what an alternating EMF is. All right, everyone? Okay, moving on. Graph questions, very, very important. All you have to do is take care of the basic concepts. Next question. Everyone, next question. Yes, I was initially at Grade Up. My name is Avinash Kumar. I take classes sometimes of physics and chemistry. I used to be at Grade Up. Before that, I was at Merit Nation. Now I am a master teacher at Vedantu, and I take care of content at Vedantu. Anyway, so a metallic rod of length L is tied to a string of length 2L and made to rotate with an angular speed of omega, right? On a horizontal table with one end of the string fixed. If there is a vertical magnetic field B in the region, the EMF induced across the end is. Very typical question. ये table है, right? And vertical EMF है, vertical magnetic field है यहाँ पे. Yeah, vertical EMF है यहाँ पे, right? Going up or going down doesn't matter. The important point over here is कि ये जो rotation है and जो आपका magnetic field है, they are both perpendicular to each other, right? This is the plane of rotation and this is the magnetic field, right? जब ऐसी situation, now that is one part of it. दूसरा part understand करते हैं. Whenever you have this situation, right? उस केस में हम EMF कैसे निकालते हैं? EMF is given by B into L cross V, right? Everyone? That is what EMF is given by. Right now यहाँ पे important part जो है, that important part is कि yeah, these two are perpendicular to each other. This is L and this is V, so we can simply write it as BLV. So this is the formula that we are going to use. The formula that we are going to use, right? अब आते हैं इसके ऊपर. This is something, इसके हर एक point की velocity is different. Why? Because it is rotating. अंदर की velocity ज़्यादा है, बाहर की velocity कम है, right? Is that right, everyone? Thank you, Samri. Right, everyone? So the velocity is changing from here to here, but what is not changing? Omega is not changing. Omega तो constant है. Angular velocity constant है. Actual velocity might change. So let me do one thing. Let me write velocity as omega r. Right? अब जैसे जैसे r vary करेगा, velocity vary करेगा. I need velocity over here. Let me do one more part. मैं यहाँ पे एक ये rod बनाता हूँ. Let me define a very small element over here, dx. This is at a distance of x. सिर्फ इस छोटे से duration में what is the EMF that is induced? सिर्फ इतने छोटे से duration में what is the EMF that is induced? Let's find out. B into x, right? Whatever is the L, B into x multiplied by d, your velocity, which is omega. Wait, sorry. Yeah, B into omega into x multiplied by dx, right? This is the length dx. So L is equal to dx, V is equal to omega r, which is omega x, right? And this is B. This is essentially the EMF that is induced in this small segment. अब इसी को आप integrate कर दो कहां से कहां तक? This part is 2L, this part is 3L. So 2L to 3L integration and you will have your answer. What is the right answer, everyone? What is the right answer? ये बस इतना इंटीग्रेट करना है आपको. B कांस्टेंट है, ओमेगा कांस्टेंट है, राइट? B कांस्टेंट है, ओमेगा कांस्टेंट है. इन दोनों को बाहर ले लेते हैं. अंदर सिर्फ x dx है. इंटीग्रेशन इज वेरी सिंपल. इट विल बी x square by 2. When you integrate this, what will you get? What is the right answer? I don't know the right answer. D. Some people are saying C. Why is velocity changing? Okay, I will answer that. D. Are you sure? D. Okay, all right. I'll go with D. Majority is never wrong, right? So D is the right answer. Everyone, this is right. This is very, very straightforward, right? I hope nobody has an issue with this part. Nobody has an issue with this part, right? यहाँ तक clear है. अब मैं छोटा सा time लूँगा यहाँ पे और बताऊँगा कि velocity क्यों change हो रहा है. In general, in any circular orbit, right, the velocities of each of these points would be different, right? इस पॉइंट की वेलोसिटी विल बी टू फास्ट, इसकी थोड़ी कम होगी, एंड सो ऑन एंड सो फोर्थ, राइट? सो दैट इज व्हाई द वेलोसिटी चेंजिंग. बट क्या चेंज नहीं हो रहा है? क्या चेंज नहीं हो रहा है? ओमेगा चेंज नहीं हो रहा है. ओमेगा इज कांस्टेंट. एंगुलर वेलोसिटी इज कांस्टेंट और ओमेगा को मैं आर से मल्टीप्लाई करूंगा तब मेरे पास वेलोसिटी आ जाएगा. ओमेगा को मैं आर से मल्टीप्लाई करूंगा तब वेलोसिटी आएगा. एज आर इज चेंजिंग, वेलोसिटी इज चेंजिंग. ओके, ग्रेट, फैंटास्टिक. Yeah, all right. So velocity goes on increasing as I go from one end to the other end and so on and so forth. Yes, exactly. You can think of it as a solar system, you can think of it as a string, anything. Right? You can simply think of it like this कि same amount of time में ये particle यहाँ से यहाँ जाता है, distance covered is 2 pi small r, same amount of time में ये particle यहाँ से यहाँ जाता है, the distance covered is 2 pi capital R is greater than small r, same time में ज़्यादा distance travel कर रहा है, speed is higher. Okay? Shall we move on? Okay, all right. Next question. Now, this is a question that I don't really need to explain. ये question मैंने सिर्फ एक छोटे से point को prove करने के लिए लिया था, right? Otherwise, this is the same question that we did. A thin semicircular conducting ring radius r is falling through the plane of in a vertical plane where you have a horizontal magnetic field. Magnetic field horizontal है और ये ऐसे गिर रहा है, right? Magnetic field is like this. This is falling like this. Again दोनों perpendicular है, essentially cross product नहीं करना है, is the idea, right? At the position m and q, the speed of the ring is v. यहाँ पे इसकी speed जो है वो v के बराबर है. Then the potential difference developed across the ring is, right? अब इसका जो potential difference हमें निकालना है, right? Yes, exactly. यहाँ पे जो हम potential difference निकालेंगे, there is one small part where you would make a silly mistake. This is the only part where you would make a silly mistake. The silly mistake that you would make is, for example, ये निकालने के लिए मैं क्या करूँगा? I will once again apply that same formula, right? The potential difference V or E or whatever is basically BLV, right? BLV होगा. V तो पता है हमें और B भी पता है हमें. What is L here? Now there are two options. Some of you will take L as pi r. Some of you will take L as pi r, and in that case your answer will be C, right? However, यहाँ पे जो मैं इन दोनों points के बीच का gap लूंगा, that will be this, the shortest distance between them. Exactly. Thank you. So this is incorrect. L is actually equal to 2r, the diameter, right? So BV and 2r, right? So BV and 2r, this is the right answer. Right, एक ही option है. However, let me take a little bit of more of your time and tell you कि why Q is at a higher potential. Why? Because यहाँ पे options काफी easy हैं. As soon as you figure out कि 2RBV is the right answer, you have the right answer, right? But let's say यहाँ पे option होता कि 2RBV and P is at a higher potential. How would you do then? How do you figure out which point is at a higher potential? Everyone, thank you. Desi Ramp Stars, everyone. Yes. Use the left hand rule, or as I do, I just use the cross product. ये जो L cross V है उसका cross product मैं use करता हूँ, right? So when you use the cross product, you will realize that all the positive potential will, the charges will move in this direction. The higher potential will be in this region. This will be at a lower potential. That is how I solve it, right? Right? So in general, when this is moving down, the charges will feel a force in this particular direction. That is why more positive charges will accumulate here, negative charges will accumulate here. This will be at a higher potential, this will be at a lower potential. Therefore, Q is at a higher potential. Use the basic principle always and you will never ever go wrong. Yes. Okay? Okay. Great. Everyone, fantastic. Next part. A rectangular coil of metallic wire is placed in a uniform field of 30 millitesla with its plane perpendicular to the field. If the area of the loop is shrinking, at a constant rate of 0.4, the induced EMF is how much? This is again a question of induced EMF. However, this is again a question of induced EMF, but however, how will you do this? Do it again by first principle. Induced EMF is given by minus d phi by dt, right? अब phi निकालने का एक बहुत ही बेसिक तरीका, phi का बेसिक डेफिनेशन क्या है? What is the basic definition of phi? The basic definition of phi is the amount of field that there is. Flux, in general flux का बता रहा हूं मैं, चाहे वो magnetic flux है या gravitational flux है या electrical flux है, doesn't matter. Right? Flux निकालने का basic तरीका is, the definition of flux is, what is the amount of magnetic field passing through a certain area? That is it. राइट. सो डी बाई डी टी, बी इज कॉन्स्टेंट, बी बाहर निकाल लेते हैं, ए इज चेंजिंग. यू नो द वैल्यू ऑफ डी ए बाई डी टी. इस रेट से ये रिड्यूस हो रहा है, राइट. सो सब्स्टिट्यूट दैट वैल्यू ओवर हियर, सब्स्टिट्यूट दिस वैल्यू ओवर हियर, एंड यू विल हैव योर फाइनल आंसर, राइट. 30 into 0.4, 12 MB, right? Is that fine everyone? 12 millivolt, वो मिली टेस्ला था, millivolt. Take care of the units, right? So again, stressing on the topics which are important, right? EMF, induced EMF के जितने possible variations हो सकते हैं. Yes, these are all very easy questions. Induced EMF के जितने possible, you know, definitions or processes हो सकते हैं, do that. That is the only very very important topic that will be asked from this chapter. Induced EMF बहुत ज़्यादा पूछा जाता है इस chapter से, right? Yes, yes, you could use that, Anirudh. Absolutely, absolutely, you could use that. It's essentially the same thing. Okay, is that fine? Now, next part. An air solenoid has 1000 turns and is 1 meter long. Its cross-sectional area is 10 centimeters square. Its self-inductance is. Do I need to solve this question? Is my question to you guys. आपको self-inductance निकालना है. आपको N दिया हुआ है, L दिया हुआ है और A दिया हुआ है. You are given N, capital N. You are given L and you are given A. You have to find out capital L. Right? So once again, self-inductance पे, okay, someone who can help me with the formula here. Okay, Samreen, I will do that in a very short while. Anyway, the formula is mu naught N square A by L. You have the value of A, you have the value of N, you have the value of L, you know the value of mu naught. Right? Everyone, very straightforward, very simple. Make sure that you know you do not forget the formulas. I'm not solving it further. The answer I believe is, what is the right answer over here, everyone? Sabhyata Singh. You could do that. Yes, you could find out the total flux and you could equate it with Li. I will get cancelled out. That is how you'll derive this formula and end up with the answer. Absolutely. Very good. C. In majority of you are saying C. I'm going with C. Very good. I'm not solving it. Like I said, substitution of formula, right? Which point is at higher potential? Okay, let me go back to that one. Yeah. See, in general, let's take a situation. ये यहाँ बहुत खाली space है. Focus on over here. If I have a point, yeah, let's use this, right? If I have a point, if I have this line, right, and magnetic field is, let's say, you know, inside, and this is moving in this direction, velocity this, right? How do you find out EMF in general? EMF निकालने का generally क्या तरीका है? B into L cross V, right? Everyone? Okay? Yes, yes. So this is the theory part. Now, ये जो दो points हैं, right? Use your so I generally use the cross product part to help me with this, right? So this is the magnetic field. Right, this is the V part. ऐसे करूंगा मैं इस तरफ. The charges should essentially move. Right, the charges should essentially move in this direction. अगर कोई positive charge है उसके अंदर, it will move in this direction. Which means as this moves down, the positive charges will accumulate here, the negative charges will accumulate here. That is how you know. That is how you know. Right? Or you can learn it. दूसरा तरीका है कि आप याद कर लो. But the way I remember is कि यार अगर यहाँ पे एक पॉजिटिव चार्ज होता तो उसको किस डायरेक्शन में फोर्स मिलता. अगर उसको इस डायरेक्शन में फोर्स मिलेगा, सारे पॉजिटिव चार्जेस यहाँ आ जाएंगे. ओके, ऑलराइट एवरीवन, इट्स वेरी सिंपल. यूज योर राइट हैंड. आप देखो कि V कहाँ पे है. ओके, दिस इज V एंड दिस इज L एंड यू नो द मूवमेंट विल बी ओवर हियर. इज दैट फाइन? डायरेक्शन ऑफ L. Teach only. See, I'm trying to teach both. Okay. Is that fine, everyone? Is this better? B और V का डायरेक्शन तो हमें मालूम है, right? So this is the force, right? Force is L into V cross B. This is your V, this is your B. Put your hand, the first thumb around the first one. अगर आपके पास एक वेक्टर है A और दूसरा वेक्टर है B, put thumb along A, rest of the hand along B. किस साइड उंगली कर्ल हो रही है? That is your direction, right? A, B, A cross B. A, B, A cross B. Okay? So this is V, this is B. Right, so this is your V and अंदर की तरफ B है, something like this, right? Force will be experienced in this direction. अगर ये positive charge है, ये इस direction में जाएगा. Is that fine? Yeah. So whatever is the first vector, इसके around thumb डालना है. बाकी का हाथ 4 fingers should be around B. Curling gives you A cross B. Is that fine, everyone? Great, fantastic. We did this question, I believe 12 answer आया था, right? Okay. And we did this question also, direct formula apply करना था. Okay. Next question. 2 coils are wound on the same iron rod so that the flux generated by one also passes through the other. So this is a question on mutual inductance, right? Yeah. So एक सवाल mutual inductance का, that is fantastic, Heath. Right, generated by one and also passes through the other. The first coil has 100 turns, the second coil has 200 turns. 2 ampere current flows through the first one. The flux is also given to you. The coefficient of mutual inductance is what? Mutual inductance ka coefficient, as in whatever is the mutual inductance, that is what we want to find out over here. How do you find this out, everyone? How would you solve this question? Okay, all right, let's see. So I have, right, the EMF can be given to me by 2 ways. One is N into d phi by dt, right? It can also given to me by M into di by dt. This is the formula for mutual inductance. Is that right, everyone? This is secondary, this is secondary. So whatever is the EMF induced in the second coil, whatever is the EMF induced in the second coil, that is equal to d phi by dt, basic definition, or that is equal to M into di by dt, that is the new definition. Okay, mutual inductance जब आप पढ़ते हैं तो आप ऐसे पढ़ते हैं. Is that fine, everyone? So अब इसको भूल जाओ. This is exactly what we are going to use. dt gets cancelled. You know the value of ns, I believe. Ns has 200 turns. So 200, right, into d phi upon di is equal to m. d phi पता है क्या हमें? Well, we know that initially the flux was 0, बाद में the flux was equal to 2.5 into 10 to the power minus 4, right? So this comes out to be 200 into 2.5 into 10 to the power minus 4 divided by, initially the current was 0, later on the current was 2. So essentially इसको ऐसे लिख सकते हो आप. You can write it like this, doesn't matter, but this is how you will find out M. Is that fine, everyone? So this comes out to be 100, right? And you will get how much? 25, right? B, very good, very good. That is exactly right. Okay. Is that fine, everyone? Anyone who has any questions? Great, great. Next part. Wait, this is the previous question, right? Yeah. Next part, an average current of sinusoidally varying alternating current. So now we are starting AC, everyone, very important, right? AC है एक जिसका peak value आपको given है 5 amperes, right? Sinusoidally varying alternating current of peak value 5 amperes and initial phase 0, right? Between the instant t is equal to t by 8 and t is equal to t by 4. Average value निकालना है, again definition, right? What is the definition for average current? Yeah, definition for average current is what? Total charge निकाल लेते हैं. For example, आप average velocity कैसे निकालते हो? How do you find out average velocity? Average velocity is total distance upon total time. Current is defined as charge upon time. So average current will be total charge that passes divided by total time. Is that right, everyone? First principle, simple. Average current हम ऐसे निकालेंगे. Okay. So let me write that mathematically. अब इसको मैं mathematically लिखता हूं. Mathematically हम इसको कैसे लिखेंगे? Mathematically we'll write this as I is equal to whatever was the I, right? Whatever was the I times dt. So this is the total charge that will travel divided by integral of dt. This is the total time that would have elapsed. Mathematically, can I write it like this? This is total charge, this is total time, right? I into t will give me charge, just integration of t will give me total time, right? So this is essentially what we are going to do from t by 8 to t by 4, again t by 8 to t by 4. Is that fine, everyone? Anyone who has any questions so far? राइट ये इंटीग्रेशन. अब यहां पे आपको दिक्कत कहां आएगी? आई क्या है? व्हाट इज आई? दैट इज व्हाट यू वांट टू फाइंड आउट, राइट? सो आई के लिए यू आर गिवन दैट द पीक वैल्यू इज 5 एंड द इनिशियल फेज इज 0. इनिशियल फेज 0 मींस इट इज साइन नॉट कॉस. सो यू विल राइट आई एज 5 sin omega t. So when t is equal to 0, initial phase is 0, right? When t is equal to 0, initial phase is 0. So I is equal to 5 sin omega t. Substitute that over here and integrate this. You should have the right answer. Okay? Is that fine? You should have the right answer. क्या आंसर आएगा इसमें? What is the final answer that you are getting after integrating this part? Why not tan? Because your current or EMF, they are either sine functions or cos functions, right? I mean, all of them are sine functions. When they have a phase difference of pi by 2, they become cos functions. But वो sine या cos ही होते हैं, tan नहीं होते हैं. It is a sinusoidal. Tan is not sinusoidal. This is tan. This is not sinusoidal, right? Okay, what else? Why cos? Cos तो मैंने लिखा ही नहीं है, मैंने sin लिखा हुआ है. Okay, integrate नहीं हो रहा है. All right, let's integrate this part. So I have integration of 5 बाहर ले लेता हूं मैं, sin omega t dt, right? यहां पे मेरे पास आएगा t by 4 minus t by 8, which can be written as 8 by t. Right, sin omega t can be integrated as 1 upon omega minus cos omega t from whatever t by 8 to t by 4. Is this what everyone is getting, everyone? And इसके बाहर write down the rest of the stuff. 40 upon t. Let me substitute omega. Right, omega को you can write it as 2 pi by t. t gets cancelled. यहाँ पे आपके पास 2 pi भी चला गया है. There is a minus sign over here. Yeah. Is that fine, everyone? Now अब तो easy है, अब तो substitute कर देंगे. Okay? अब तो substitute कर देंगे हम लोग. All right. Why not cos omega t initially? Because it said that the initial phase is 0. Cos omega t में when you take cos omega t and you put t is equal to 0, what do you get? You get 1, right? You don't get 0. Okay, so इसलिए cos नहीं लेंगे. We'll start with sin. Great, fantastic, very good. So everyone, what is the final answer over here? I believe someone is saying A, 2 people are saying A, 1 person is saying C. All right, so integration यही है, ऐसे ही integrate करेंगे. All right, let me explain the process once more. The process is very simple. Average current निकालना है, so you are finding out total charge, you are dividing it by total time. आप total charge निकालेंगे, उसको total time से divide करेंगे. निकालने का तरीका क्या है? Integrate I with dt divided by integration of dt, right? So that is how we will solve this. All right, next question. Now ये जो question है, I don't want you to solve it. The reason why I took this question is because there is a concept that I want to highlight, but this is इस तरीके का सवाल, इन वैल्यूज वाला सवाल आपके पास जेई मेन में नहीं आएगा. इन वैल्यूज का सवाल आपके पास जेई मेन में नहीं आएगा. ओके, इज दैट फाइन? बट देयर इज अ कॉन्सेप्ट दैट आई वांट टू हाईलाइट. जो कॉन्सेप्ट मैं हाईलाइट करना चाहता हूं, दैट इज एसी में देयर विल ऑलवेज बी अ क्वेश्चन व्हिच विल आस्क यू टू यूज फेजर डायग्राम्स. Okay, ऑलराइट, सो यहां पे हमारे पास ऑल्टरनेटिंग ईएमएफ है जिसकी फ्रीक्वेंसी गिवन है. इट इज अप्लाइड टू अ सीरीज सर्किट ऑफ रेसिस्टेंस, इंडक्टेंस एंड कैपेसिटेंस. All you have to find out is whether voltage leads current or current leads voltage. दोनों में से एक चीज फाइंड आउट करनी है. How do we solve this question? Draw that phasor diagram. Yeah, draw that phasor diagram. All of you know that this is R. यहां पे आपके पास ओमेगा L आएगा और यहां पे 1 upon omega C आएगा. Right? This is where the current is. This is where the current is, right everyone? Also, depending on दोनों में से क्या बड़ा है, ये बड़ा है या ये बड़ा है, दोनों में से whichever one is bigger, that will decide कि EMF lead करेगा या EMF lag करेगा, right? For example, assume that ये this is the value of omega L and this is the value of 1 upon omega C. What is the net? The net will come out to be somewhere over here. EMF leads, right everyone? EMF will lead. On the other hand, assume that assume that this is your omega 1 upon omega C and this is omega L. ये बड़ा है, so somewhere over here will be the resultant. EMF lags, right? And you can find out how it lags. This is the angle by which it lags. So this is the phi. So ये जो angles यहाँ पे given है 1.73 और 3.73, that is the phi that you have to calculate, right? Now the values which are given over here are complicated, right? The values that are given over here are complicated. Therefore ये phi निकालना थोड़ा मुश्किल हो सकता है. But let's try and find out whether voltage leads or current leads. इतना तो निकाल सकते हैं. Let's see. So what is R over here? R is 20 ohms. What is XL over here? XL is equal to omega L is equal to 2 pi, right? 2 pi 50 into 100 into 10 to the power minus 3. Take care of the units always. Right, so this comes out to be 10 pi. Is that fine everyone? What is XC equal to? XC is equal to 1 upon omega C, which is equal to 1 upon 2 pi into 50 into 30 into 10 to the power minus 6. Right? Now when you solve this, essentially you will arrive at 10 to the power minus 4. So you will have 6 pi, right? Now obviously XC is greater than XL. Anyone who follows this part, XC will be greater than XL. यहाँ पे XC XL से बड़ा होगा. This is 10,000 divided by 6 pi. This is 10 pi, right? And therefore we know that current will lead. So it's either one of these two options. It's either one of these two options. इतना ही explain करना था मेरे को. बाकी you can find out the value of this angle. How do you find out the value of this angle? Everyone, the value of this angle मैं formula बता देता हूँ, right? मैं formula बता देता हूँ. This angle right? So this basically is XC minus XL and this is R. So if you want to find out phi, what do you do? Tan phi will be equal to XC minus XL upon R. You have all of these values, substitute this and you will get the final answer. Okay? Is that fine? नहीं, अगर कैपेसिटर लीड कर रहा है तो अगर कैपेसिटर ज्यादा है, if the capacitive impedance is higher, in that case, right, if the capacitive reactance is higher, in that case current leads. एक बार फिर से मैं वो डायग्राम दिखा देता हूं everyone. This is current. This will always be in the direction of resistance, right? This is your omega L, which is basically XL, right? This is your XC which is 1 upon omega C. अगर ये बड़ा है, in that case EMF यहां आएगा. This is going down. It is not leading, it is lagging. Right? Current is leading in this case. Current is leading in this case. On the other hand, let's say this is higher. Right? The EMF goes up, it leads. Is that fine? So it is all a play of whether capacitive reactance is higher or inductive reactance is higher. Okay? Whether capacitive reactance is higher or inductive reactance is higher. Alright? No, you can take XL minus XC as well, doesn't matter. What you have to find out is which one is bigger. दोनों में से बड़ा कौन सा है? You have to find out the difference. Okay, next question. You have an LCR circuit with 100 ohms resistance. This is connected to an AC source of 200 volts. Angular frequency भी given है. And by the way, this is directly angular frequency. Keep that in mind. When the only capacitance is removed, the current lags behind the voltage by 60 degrees. So ये LCR circuit है. LCR circuit में से, Sai, I answered that, right? You can take XL minus XC as well. अगर XL बड़ा है, तो then XL minus XC will be positive. Your voltage will lead. Right? If XL minus XC comes out to be negative, it means voltage will lag. You can take it either ways, doesn't matter. Right? Okay. The important part is which one is bigger. Now coming back to this question, you have an LCR circuit. इस LCR circuit के values आपको given है, resistance, voltage and omega. अगर capacitance हटा दिया, if I remove capacitance, in that case current lags behind by 60 degrees. In that case current lags behind by 60 degrees. Right? जब मैंने inductance हटा दिया, then current leads by 60 degrees. This is the question, everyone. Now let me draw this for better clarity. Yeah. So I would have some XC, I would have some XL, and I would have some R over here. Is that right, everyone? Now, first situation number one is ये exist नहीं करता, इसको भूल जाओ. अगर ये exist नहीं करता, in that case, this is the resultant, and they are saying कि ये 60 degrees है. And you can see this is EMF leading current by 60 degrees. EMF is leading current by 60 degrees. This is the situation when this doesn't exist. Let's take the second situation जिसमें this doesn't exist. सिर्फ ये exist करता है. उस केस में the resultant will be this. उस केस में current leads EMF by 60 degrees. Tell me something. एक छोटी सी चीज मुझे पूछनी है. अगर ये दोनों एंगल इक्वल हैं, अगर if these two angles are equal, अगर ये दोनों एंगल इक्वल हैं, ये R भी सेम है, can I say over here that XC will be equal to XL? For this particular situation, XC will be equal to XL अगर ये सब सेम आ रहा है तो. We can say that, right, everyone? काफी straight forward है. ये भी 60 है, ये भी 60 है. This particular part, right, tan 60 is equal to R upon or XL upon R, and ये वाला tan 60 is equal to XC upon R. Obviously XL is equal to XC. Great, fantastic. So XC is equal to XL, right, everyone? Okay, अगर XC और XL आपस में इक्वल हैं, वेरी गुड, थैंक यू अनिमेश, राइट. अगर XC और XL आपस में इक्वल हैं, देन दिस इज अ रेजोनेंस वाला सिचुएशन. अगर रेजोनेंस वाला सिचुएशन है, इन दैट केस करंट इज गिवन बाय जस्ट V by R, राइट. करंट इज जस्ट गिवन बाय V by R. ओके, V by R कैसे निकालेंगे आप? 100 ये है, 200 ये है, डिवाइड कर दो, राइट. 200 upon 100, that is 2 amperes. Very straightforward. The only thing that we want to figure out is XL XC में आपस में क्या relationship है. The only part I'm stressing over here is make sure this phasor diagram वाला part आपने अच्छे से किया है. Alternating current का question एकदम solve हो जाएगा. So that is one part जहां से सवाल आता है. The other part जहां से सवाल आता है in alternating current is power. The other part जहां से सवाल आता है in alternating current is power. So let's take a look at this question, everyone. The power factor of a series RL circuit is 1 upon root 2. Power factor आपको दिया हुआ है. If the frequency of the applied AC is doubled, the power factor becomes what? Okay. What is the final answer? जल्दी से बताओ. In the meantime, let me see how to do LCR circuits in parallel. Arnab, first of all, that is not in your syllabus. Therefore, you do not want to do that right now. Right? अभी आपके पास 4-6 दिन बचे हैं. Do not go into a new topic. That is not required. Series LCR is what is in your syllabus. That is it. Okay? Is that fine? Now, if you are curious कि नहीं मैं मुझे तो वो करना ही है, apply the same, so go through the derivations. If you want to go that level higher up, in that case go through the derivations. आपने series वाले का कैसे derive किया था? Use that same process to derive for the parallel. Okay? All right, everyone. So the power factor is given to you. Let's figure out what is power factor. Power factor is given by what? Power factor is given by cos phi, right? The definition of power factor is cos phi, where phi is the phase difference. What is cos phi equal to? जो भी phasor diagram है मेरा, right? This is an RL circuit. So R XL, right? जो भी मेरा यहाँ पे phi आ रहा होगा, cos phi will be equal to what? Cos phi will be equal to R upon square root of R square plus XL square. Is that right, everyone? Okay, R upon square root of R square plus XL square. Is that right? ये cos phi यही आएगा. So this is the power factor. अब इसमें एक थोड़ा छोटा सा चेंज करते हैं. This is equal to what? This is equal to 1 upon root 2. Solve this. What do you get? 2R square is equal to R square plus XL square, or R square is equal to XL square. Right? Everyone यही आ रहा है? In other words, I can write this as omega square L square. Omega चाहिए मेरे को क्योंकि आप omega change कर रहे हो. You are changing the frequency. Because it is said that it is an RL circuit. Right, Vishal? So RL circuit दिया है इसलिए XL use किया है. अगर RCL circuit होता, I would have used all of them, so on and so forth. Okay, so this is what I get. Right now, think of a different situation. Right, cos phi dash. Cos phi dash will be equal to what? Cos phi dash will be equal to R upon square root of R square plus XL dash का square. Frequency जैसे ही आपने double किया, what is XL dash equal to? XL dash is equal to 2 omega L. Frequency is doubled, so XL dash is equal to 2 omega L. Right? Substitute कर देते हैं यहाँ पे. Too much. Okay. R square plus XL dash square. Right? Power factor. Okay. Right? So once again, R upon square root of R square plus, this is how much, everyone? Can I say this is equal to 4R square? Omega L is equal to R. So twice of omega L is equal to twice of R. Twice of R का square is 4R square. So this comes out to be 1 upon 5. B is the final answer. Okay? Because आप frequency change कर रहे हैं ना. When you are changing the frequency, resistance पे तो कोई impact नहीं पड़ेगा. Right? XL पे impact पड़ेगा because XL contains omega. Right? Very good, very good. Great. Moving on. So you have an AC circuit, instantaneous EMF and current are given by these values, right? So you know that phase difference is pi by 4, right? Phase difference is pi by 4. In one cycle of AC, the average power consumed by the circuit is, how do you find out average power, by the way? Average power कैसे निकालते हैं हम? एवरेज पावर कैसे निकालते हैं? एवरेज पावर इज इक्वल टू वी आर एम एस इंटू आई आर एम एस इंटू कॉस फाइव. हेंस दैट इज वाई दिस इज कॉल्ड द पावर फैक्टर. राइट? सो लेट्स फाइंड आउट. 100 अपॉन रूट 2 इंटू 20 अपॉन रूट 2 इंटू कॉस फाइव. फाइव इज पाई बाय 4. So cos pi by 4, which is 1 upon root 2. कितना है ये? This is 2, this is 10, 1000 upon root 2. That is your average power. What is the definition of wattless current? Wattless current is equal to whatever is I naught, right, IRMS multiplied by cos phi. That is wattless current, right? And this is equal to what? 20 upon root 2 into 1 upon root 2 is equal to 10. So 1010 C is the right answer. Again, these are definition based questions. Make sure. So the idea over here is, someone was asking me earlier, क्या मैं AC छोड़ दूं? क्या मैं EMI छोड़ दूं? Should I leave AC and EMI? The idea over here is, no, do not leave AC and EMI. Directly formula based questions आते हैं. All you have to do is go through the chapter once, remember the formulas, practice some formula based questions. That is it. The phasor diagrams are just vectors. अगर आपने काइनेमेटिक्स पढ़ा है, अगर आपने फ्री बॉडी डायग्राम्स बनाए हैं, तो फेजर इजी है. ओके, ऑलराइट. So next, moving on to electromagnetic waves, and this is where we will stop, everyone. I have 2 more questions, right? So Chaitanya, this is what I said. I said that do not skip AC, EMI and EM waves, because the questions which are asked from them are directly formula based, right? All you need to see, whatever questions we did, all of them were done by first principle. All of them were done using definitions. Right, the definitions of EMF, the definitions of induced current, the definitions of flux, the definitions of phasors, the definitions of power, and so on and so forth. And yes, these are sufficient. I mean, not just these, but these are important topics. Now, E and B represent the electric and magnetic field vectors. The direction of propagation of electromagnetic wave is along what? This is a question which has been asked too many times in JEE Mains. Do not be surprised अगर दोबारा पूछ लेंगे तो. Okay. So E और B अगर दो इलेक्ट्रिक और मैग्नेटिक फील्ड के वेक्टर्स हैं, then electromagnetic wave is always perpendicular to them. It is always perpendicular to them. The answer is E cross B, right? Is E cross B. Another question, ये काफी सारे स्टेट एग्जाम्स में आ चुका है एंड जेई मेन में भी आ चुका है. वेरी वेरी इजी क्वेश्चन. द स्पीड ऑफ गामा रेज, एक्स रेज एंड माइक्रोवेव्स इन फ्री स्पेस इज Vg, Vx and Vm. Tell me what is the right answer. Everyone, what is the right answer in this question? It's a very very simple question. आपके पास 3 तरीके की रेज हैं. इन फ्री स्पेस what is their speed? Yes, so in free space they all travel with the exact same speed, and the answer is this. In free space they will all travel with the exact same speed, and therefore A is the final answer. All right, everyone. So that is all that I had for today. Speed of light, exactly. The speed over here is speed of light. Okay, and speed of light is given by E naught upon B naught. So that is one more formula that you can use to figure out electric field if magnetic field is given, and magnetic field if electric field is given, right? Yes, electromagnetic wave से एक सवाल हमेशा आएगा JEE Main में. That सवाल can be completely knowledge based, or that सवाल can be from one of these formulas. Yes, the next class will not be tomorrow. The next class will be day after tomorrow on 1st. That is when we will start modern physics. Right? That is when we will start modern physics. Okay? Is that fine, everyone? No. It wasn't A, it is B. Agreed. I told you B only. I told you all of them are going to be equal. Right? So, the next class is going to be 1st of Jan in the new year. This is the final class of this year. Right? Everyone, all the very best. Optics will be taken by Namo Sir. All of you want Namo Sir, so I had to convince him कि optics ले लो कम से कम. Right? And he had to find some time, so he's available on 3rd. He'll be taking optics then. I will finish off modern physics part 1 and part 2 on 1st and 2nd. Modern physics is extremely important. इसीलिए उसको 2 classes दी हैं. You might have noticed कि अभी तक 12th में मैंने किसी को भी 2 classes नहीं दी हैं. Right? Okay. So I'm sure all of you are aware of the schedule, right? So by the way, anyone who wants to take a break now, essentially the class is over. Thank you very much. Take care of yourself. In the meantime, let me show you the schedule. So your upcoming class is this. Yeah, your upcoming class is on fluids part 2. The next class is fluids part 2, right? And after that the class is at 9 o'clock the class is trigonometry, and after that the class is coordination geometry. Is that fine, everyone? This is where we will stop. See, modern physics say only from semiconductors about 3 questions have been asked in some or the other years, right, Mohan? बाकी का मॉडर्न फिजिक्स अगर मैं मिला दूंगा तो उसका वेटेज बहुत हाई हो जाता है. ओके, एंड मॉडर्न फिजिक्स इज सो व्हाटएवर यू फाइंड इन बुक 2, राइट, इलेक्ट्रोस्टैटिक्स, मैग्नेटिज्म, करंट इलेक्ट्रिसिटी के बाद जितने चैप्टर्स हैं 12th में, दे आर ऑल वेरी सिंपल. सेम इज ट्रू फॉर 11th स्टैंडर्ड एज वेल. मैकेनिक्स, रोटेशन के बाद के जितने चैप्टर्स हैं, इलास्टिसिटी, फ्लूइड्स, थर्मल, एसएचएम, दे आर ऑल कंप्लीटली इजी. दैट इज व्हाई इनका वेटेज हाई है, राइट? बाकी बट कंबाइंड वेटेज इज बिकम्स वेरी हाई. All right, yes, happy new year everyone, right? A very very happy new year in advance. I hope that the next year is going to be very a huge milestone in your life, right? You would achieve huge things. But let me take this very small opportunity to mention one small part over here. Success, your success in your life will not be defined by your success in JEE Main, right? आपका जो सक्सेसफुल होना या नहीं होना is not dependent on JEE Main or for that matter JEE Advanced. I know a lot of my friends who are IITians but were unable to do anything with their lives later on. I know a lot of my friends who are not IITians for that matter, they are not even NITians, and they were able to achieve a lot. Okay? However, now अगर मैं ये बोलूंगा, in that case your question would be, sir JEE Main देना ही क्यों है? राइट, आप बोलेंगे JEE Main देना ही क्यों है? द रीजन इज रिग्रेट. Even the people who are successful without clearing JEEs were regretting. They regretted कि यार मैंने उस टाइम पढ़ा नहीं तो आगे का रास्ता थोड़ा आसान होता. The road to success would have been easier अगर मैंने पहले से पढ़ लिया होता. Right, everyone? That is it. That is the only difference. अगर आप अभी तैयारी करेंगे, if you go into a better college, the road to success will not be guaranteed. It will just be easier. अगर आप अभी तैयारी नहीं करेंगे, आपको बाद में फाइट मारनी पड़ेगी. One of my maths sir, when I was in 10th standard, he said that it doesn't matter when you want to work hard. You can work hard right now or you can work hard when you are 35. Right? Doesn't matter either ways. If you want to be successful, you have to work hard. But if you work hard now, when it is your age, later on will be very easy. Working hard at 18, 16, 17 is easier. Working hard at 35 is extremely difficult. Okay? सिर्फ क्लास 12th का syllabus is not sufficient. Mohsin, what you can do is you can do some topics. For example, make sure you do thermal, SHM and waves, right? And make sure you do kinematics of 11th standard. इतना तो कर लेना. अभी से do not think about drop. Dropping is a bad idea. It's an extremely bad idea. At this point of time, thinking about dropping is a bad idea. Think about dropping once you have your results. Result आने के बाद I'll tell you a trick how to decide whether you want to drop or not. अगर आपका result आया, let's say you scored 30,000 rank and you decide कि यार इस बार ना मैंने अच्छे से तैयारी नहीं करी थी. I very clearly know that this is what I could have done extra and ये 30,000 could have been 300. Take a drop. अगर आपका रिजल्ट आया, you have 30,000 rank but you don't know कि और कैसे ये अच्छा हो सकता था, do not take a drop. In that case, एक साल ड्रॉप करके कुछ भी हासिल नहीं होगा. So exactly, this is something that you have to decide once the results come out. Right now you have 2 chances, not 1, 2 chances. अभी जैन में एक आ रहा है, इसके बाद एक अप्रैल में आएगा, right? You have 2 chances. उसके बाद बिट्स का एग्जाम है and there are so many state exams. Do not think about dropping. Think about your next upcoming opportunity. Make sure how you can make the best of it. We will help you out with that in any way we can. We will keep on adding lectures. We will keep on doing motivational sessions. We will keep on adding tricks and techniques and counseling sessions. We will do everything that we can to push you towards your dreams. Right? So all the very best everyone. Namo Sir's class is about to start. So I will stop here. Thank you very much. Take care of yourself and have fun. Bye-bye.